Hi, sir.
Very good evening.
Yeah, good evening, sir. How are you, sir?
I'm doing good.
Sir, and first of all, thank you so much for accepting our invitation
It's a privilege.
and coming here to our Vignan University.
Right.
So, and today's guest lecture, which happened on Potting Biotech's plot and its potential, is simply amazing, sir. So,
Thank you.
all the students are also very happy about the session.
Right.
And here are some of the biotechnology students who
Right.
wants to interact with you regarding some of the queries that they are having.
Sure.
So, how do you envision the role of potting biotechnology in the recent agricultural challenges?
Right. So, potting biotechnology's plot and potential is basically telling you how to seed that inspiration. That's what we were doing with the lecture. So, agriculture is not limited to land. We understood it's also expanding into the sea, it is expanding into the desert, and it has many variations. We talked about BT cotton and about crop rotation and about different variants where even the waste of agriculture can actually become high value products, like we talked about orange peels and even the rice bath which is actually being thrown out. So, these are extra income sources for agriculture, which agriculture industry should also tap in, and thereby changing the whole plot. Biotechnology could do that.
Thank you.
Sir, as you mentioned some points, na sir. In the same way, could you please elaborate the most important application which has potential to of potting biotechnology in the farming?
In the farming sector. So, what we actually see in terms of biopesticides is the first initial step with biofertilizers, moving away from chemical pesticides per se. So, many of the pesticides are banned, but you would know that some of them are still in use. And so, we are moving to a place where the antibiotic approach to farming moves towards more of a biophages approach, where phages will be used in mixture depending on the soil, the nature. So, it is called a cocktail based on the particular plot of land. And so, what happens is, instead of having antibiotic resistance which is getting developed and pest resistance that comes up, you have natural variants in terms of phages. So, the development of phage will be a big change in phase, not only in our therapeutic place where we could move from vaccine to phages, we could do the same, and the first step would be to move to phages in agriculture. So, that is just one indication. There are bio indicator plants which will be plants which change color depending on the climate. So, you do not need to actually wait. So, these variants are already out, they change color based on the environment. So, the color change itself tells the farmer that there is a pest attack or there is a strain which is coming. And so, there are these different applications which are there. It is not that plant may not be consumable, but that will be a sensor indication. So, I gave you a few examples.
Sir, what are the problems or the challenges that we face in plotting biotechnology, and how do we overcome that?
Right. So, when I meant potting, is actually the word is actually putting a seed in a pot. And so, we have a challenge because there is a lot of fear in the biotech community per se, because we do not know there is any hope for the industry, whether there is potential or whether there is high value opportunities. I had an opportunity to talk to the dean and say that this field also has premium jobs that we are not aware of, where there are traveling biotechnologists who carry with them the entire process. They hire factories for 3 months, stay in big plush places, travel to move tech transfer and produce 3 or 4 batches. So, there are premium possibilities, and yet we look at it as a production job. So, the threats are the fears that are there, which we should abandon and be more brave.
Sir, in your opinion, what are the key factors that will be responsible for the potting biotechnology as a focus area for farmers and the researchers?
Right. So, what is important is there is a lot of technology that we are learning, simple techniques which we are not finding practical applications for. Everything organic and going to waste, whether it is molasses and other materials, can be moved into a high value product. So what are the key areas? One is to actually learn technology in an application science rather than ape technology what somebody else is doing. There are a lot of biodiversity in India which is actually so less in cold countries. We have a lot of flora and fauna which is not genotyped, which is not explored, and the potential benefits that come are immense. We had one PhD professor in Singapore whose research mounts up to 100 papers on just a red chili. So the amount of scope what we throw by saying when it's spicy is so much that they can supply PhDs. So the challenge, the key areas is to develop the science and to go after areas that nobody else can but we can, and not be afraid that we are a Asian society and worried that we don't have the resource. We have a lot of generationally passed wealth which are not documented, which are not brought to the forefront, and we should make it documented. We should make it a technology, we should make it a royalty. These are areas, simple areas which we have but we haven't owned it.
Sir, how do you think students and young professionals can contribute to the advancements of potting biotechnology in the future?
Right. So there are these new areas which are coming up like big data, where we have even informatics has slowly lost its sheen, where big data and data sciences, data analytics and AI is coming to the picture. AI is not going to help mathematical computations, it is helping for rocket science and it is helping for projectile planning, but even so it helps for a very complex system like biology. So we need AI based modules, supercomputer based analysis of patterns where genomes are involved, sequencing is involved, where we haven't explored the area how big data can be applied to diseases. Any immunological response has 5 or 6 different immunology actions in the body. We haven't developed modeling to see how a body responds, for which we need supercomputing. And so the next big space is where supercomputing enters biology. The question is whether the computer science students will be first to learn biology or the biology students will be the first to learn computer science. And I hope that is done by the biotech students.
So thank you, sir. Thank you so much for your time and
Thank you
words.
for making it work. It is a privilege.
Thank you.